My name is Eric and welcome to Dataful. I present awesome data cases from some of the best data scientists and machine learning engineers in the world. Today I want to see if ChatGPT, OpenAI's latest large language model, can solve a coding challenge I was given as part of a recent Facebook data science interview. You would be foolish to miss this, so let's get started. Before getting started, let me give you some background on the Facebook interview process. So earlier this year I applied for a data science role in product analytics at Facebook. I had to go through 6 interviews in total, and at the end I was offered an IC5 position in data science. Levels FYI provides an overview of the different IC levels that you can expect at Facebook and the salary ranges. So an IC5 ranges in the $265,000 salary range. But keep in mind that the offers might vary from interviewee to interviewee, and it also depends a little bit on how well you negotiate. Also, for each IC level, you actually can find quite a range of salaries as proposed here on this website. So the interviews at Facebook were as follows. First, I had a 30-minute recruiter interview. That was mostly talking about my background, what this role would entail, and my salary expectations. This was then followed by a 1-hour interview with one of the data scientists, and it was kind of like a mix of coding skills, data science, and also product analytics questions. Passing this interview led me ultimately to interview day, which consisted of 4 1-hour interviews, again with different data scientists. The interviews consisted of a 1-hour technical skills interview, which I call the coding challenge, a 1-hour analytical execution interview, which was mostly about statistics, and then a 1-hour analytical reason interview, which was mostly about product analytics, and then lastly a behavioral interview. Once you pass all of those on, you will discuss your offer. So what I would like to do with you today is to find out if ChatGPT can pass the technical skills interview, aka the coding challenge. Will it provide sufficient solutions to the coding challenge? Will it provide even answers that are better than mine? Let's find out together. So what did the coding challenge look like? The coding challenge was provided to me in codapad.io, and I copied it here to Jupyter Notebook just for clarification. It read as follows. Welcome to Meta. This is just a simple shared plaintext pad with no execution capabilities. When you know what language you would like to use for your interview, simply choose it from the top down in the top bar. Enjoy your interview. And then I was given this data set with 6 columns describing the metadata of a messaging app. So just as a quick heads up, you can see that there was actually no code execution required, but I was not allowed to just write pseudocode. Secondly, I was able to choose my programming language. The data suggests that this data was generated in SQL. However, I chose Python. My SQL is pretty decent, but I feel really comfortable in Python, and the interviewer didn't really mind. So what about the data? The data is 6 columns and describes metadata of a messaging app. You can think of like Facebook Messenger or WhatsApp. They are a little bit explained here, but there were a couple of things that immediately stood out to me. So first of all, this timestamp columns is, I believe, in Unix timestamps, which means in seconds. That's really useful if you want to do some arithmetic on the date columns, and it avoids you having to use things like time deltas or PD to date time. Secondly, you can see that IDs are shared between the sender ID and the receiver IDs. And that makes total sense because in a messenger app, you can be the receiver of a message or you can also be the sender. So the sender ID 111 is the same as this one here. And there's clearly some message going on between 111 and 222. I was then given 3 questions to answer. I'm going to show the questions here, but they were given to me one at a time. But I want to make sure that you can see them actually in case you want to solve this coding interview yourself. Here are the 3 questions I had to solve in this 1-hour interview. The first question was, how many unique conversation threads are there? The second question was, what percentage of conversations in the last 40 days contain a message reaction? And then the third question was, what's the average number of days from when the conversation thread started to when the first reaction was used? And you can kind of tell that the questions get gradually more difficult. So let's start with question number 1. The one I want to do it is, first I want to show you the solution I provided and the logic that goes into it. And then we see what ChatGPT has to say about that. So multiple messages can be part of one conversation thread. And you might notice that in this data we were given, there's some nuance here because sender and receiver can be swapped, but they can be still part of the same conversations. However, there is no unique column ID that labels actually conversations of the same sender and receiver, even if those are swapped. So we have to generate a new ID that will take care of that. The way I thought about this is converting both of these columns into strings, then concatenating both strings. However, we're going to sort this by smaller number first and the bigger number also as second. So this would exactly account for these first three messages being all part in the same conversation thread. So how does this look like? I assumed that the data is already in a pandas data frame. I then slice out the sender ID and the receiver ID, and then I use a lambda function to do exactly what I just described. First, I convert each column into a string. Then I concatenate the two strings. However, I'm only concatenate the first and the second string if the first number is smaller than the latter. Otherwise, I swap the two such that the smaller number always comes first. You might also know that it's really important for this one to specify the access, because this lambda function here operates on a whole row, and I'm indexing here the columns with an index. We can then count the number of unique conversation threads in the whole data set simply using the nUnique function in pandas applied to this new function we have. And this is all it, just 2 lines of code. So let's see what ChatGPT has to say about that. I am asking ChatGPT the following. Hey ChatGPT, given the following data as a pandas data frame. Then I give it the data as I was provided it. And then I'm asking, what is the Python code to find the number of unique conversation threads? Let's see what ChatGPT has to say. To find the number of unique conversation threads in this data frame, you can use the group by and nUnique methods in Panda. Here's some example code that should do what you want. So let's look at the code that ChatGPT provides. So first, it's importing the data as a pandas data frame, as I was just suggesting it to do. Then it is a group by sender ID and receiver ID, which looks like it's already getting on the right track, right? Because we want to group by all sender and receiver IDs into different conversation threads. It then applies the nUnique on the message ID to calculate the number of unique messages within each conversation thread. That's not quite what we want, but let's see what it does at the end. At the end, it just says number of threads is just shape of 0. So it turns out that this solution is actually very, very close to what we want. Instead of nUnique, ChatGPT could have also used the size attribute here, because all message IDs are unique already per se, but that's just a minor nuance. What ChatGPT has not taken into account is that sender and receiver ID can be actually swapped and still account for the same conversation threads. So let's see if we can ChatGPT resolve that. This is almost correct, ChatGPT. However, what if sender ID and receiver ID are swapped? Can you account for that in your code? ChatGPT, of course, is very optimistic and says, yes, you can account for the possibility of the sender ID receiver IDs being swapped by adding another group statement and then combining the results. Here's how we can modify your code. So let's look at the solution again. So ChatGPT in its second solution is trying to group the sender and receiver ID twice. Once with sender ID first, and the second time with the receiver ID first, and it creates, so to say, 2 data frames. It then does exactly what it did before, counting the number of unique messages in each. That's kind of like not really needed, but it's also not harmful. And then it adds both of these data frames into one data frame and gives us the shape of the total. Unfortunately, that again does not give us the right answer. So I think we need to help ChatGPT here a little bit more. I'm asking it the following. Hey, not quite correct. Can you create a unique ID out of the sender and receiver ID column, regardless if receiver ID and sender ID is swapped, and then count the number of unique threads? Let's see if ChatGPT can now solve the problem. So the current solution is already a lot closer to what we want, but not quite right. So ChatGPT already rightfully identifies that we have to put sender ID and receiver ID into a tuple and generate actually pairs. And then we can just count at the end the number of unique pairs. However, ChatGPT is missing one key aspect, and that is actually sorting the tuple, so the smaller number is always first and we don't get double counts. So let's try to fix that. So I told ChatGPT that this is almost correct, but still double counts cases when sender ID and receiver ID are swapped. So it didn't quite get that nuanced part. But I asked it to fix it, and it did absolutely correct, you know. It's taken the sender ID and the receiver ID, very similar to what I had originally in my code. It's then taking actually both of those as a list, sorts the two, so the smaller numbers will be always first and the larger number will be it. It will turn it into a tuple and then count the number of unique conversation threads in that. I actually tested that in Jupyter, and that gives us absolutely the correct answer. So let's move on to question 2. The second question is, what percentage of conversations in the last 14 days contain a message reaction? So looking at the data, we want to do a couple of things with the data. First, we probably want to slice the data to the last 2 weeks to only count messages in this last 2 weeks. And then we want to do essentially 2 counts. We want to count the number of total messages, and we want to compare this to the number of messages with a reaction. By dividing these two, we're going to get the percentage, and this should give us the answer. How does my code look like? I'm taking the max date we can find in the column. Then I define 2-week periods in second, which is 60 seconds per minute, 60 minutes per hour, 24 hours per 2 weeks. And then we have multiplied times 2 weeks. This is the total number of seconds in 2 weeks. This allows us to define a start time. And together with the end time, we can use these 2 times to slice out our data frame now and generate all the messages in the last 2 weeks, period. So this looks like this. We take the data frame and then we do start time smaller equals the FTS, where the FTS is the timestamp column, smaller than equal the end time. We're going to use the shape 0 function just to get one number back, which tells us the total number of rows. So this is the total number of messages in the last 2 weeks. Now for the number of messages with reactions, we do exactly the same thing. However, this time we're going to use the query function to filter on all the messages that have a reaction. So the first one gives us all the messages in the last 2 weeks. The second one gives us all the messages that have at least one reaction. To not calculate the percentage, we'll just divide the smaller number by the bigger number and multiply times 100. When actually reviewing the solutions, I'm kind of realizing that this is not quite the answer to what the question is asking. I'm sure the question was asking for the number of conversation threads in the last 14 days that contain a message reaction. I provided this solution to the interviewer and they did not complain about it, so I assume it was totally fine. So let's see what ChatGPT has to say about that. So I just copied over the questions into the ChatGPT window. I'm going to ask what percentage of conversations in the last 14 days contain a message reaction, and let's see what the response is. And here's a solution that ChatGPT provides. It first imports the data again as a data frame, as we've done in solution number 1. It then starts using the datetime module and the time delta to calculate all the messages in the last 2 weeks. I've avoided using the time delta and the datetime because I wasn't super familiar with that syntax. I felt very comfortable just working in seconds, but ChatGPT masters this gracefully. As a minor nit, I want to say now might not be actually the maximum time in the data frame. I used actually the max time. So I did max time minus 14 days, but I think the interviewer would have been totally fine with this approach too, because it can be assumed that the data is going all the way until now. So what is ChatGPT then doing after we've filtered down the data frame on like 2 weeks of data? It first groups by the sender-receiver column. Remember, this is a column we've created in question number 1 to make conversation threads unique, no matter if the sender and receiver ID was swapped. It then takes the has reaction column, which is either 0 and 1, and takes the mean value. That might be a little bit confusing because I think it would be clearer if it picked the max value here. What that really gives you is 1 conversation thread per row, and the has reaction would have either a 0 or a 1. In this case, it has 0 or a number that is larger than 0 if it has reactions. So how does it calculate now the percentages with reactions? So it takes this conversation reactions data frame and just flips it to either a true or false if the value is larger than 0. So keep in mind, if all messages in one conversation threads had no reaction, the mean of it would be 0. In this case, this would be a false. If any of the messages in a conversation thread had a reaction, the mean would be larger than 0. So this equation here turns the series into a true. So now you end up with a series that has a bunch of false and a bunch of trues and has 1 conversation threads per row. If you have a binary array with just trues and false and you take the mean of it, that gives you exactly the percentage of what you want. So the solution is actually 100% correct. Super impressive. ChatGPT then also tells us that this solution assumes that we have the sender-receiver column from the earlier solution. So it's actually remembering what we have talked about in the earlier solution, and it's making use of it, which is exactly what you would want to do in an interview. So ChatGPT acts very, very similar here to a real person. It also then gives you a little hint and says, hey, if you wanted to calculate the percentage for all the messages, not only the last 14 days, you could simply remove the 2 lines of code that filters down the data frame on the last 2 weeks. So well done, ChatGPT. So this brings us to our last question in the interview, and probably the most difficult one. What's the average number of days from when the conversation thread started to when the first reaction was used? So what immediately popped into my head is that for each conversation thread, we want to get the first date of any of the messages. Then we want to get in the second step the first date of any of the messages in the conversation thread, but with a reaction. This gives us two columns, one for messages without reactions, one for messages with reactions. All we have to then to do is to subtract these two, convert it into days, and take the mean. And that is the solution I also went with. So in the first row, I'm calculating the first frame, which is all the messages, reaction or none, and then we're grabbing the minimum date. So again, we're grouping by sender ID plus receiver ID. That's the unique identifier for a conversation thread. We're taking the TS column, not the date column, and then the min value. And we're renaming it to the first message timestamp. This would give you a series, but I like to work with frames, so I'm converting this into a frame. This gives you, by the way, one conversation thread per row, and then just one date per conversation thread. Now we're defining our second data frame. We're going to do all the same steps as above, but we first filter all the messages out that don't have a reaction. So df query has reactions larger 0, gives us such a data frame without all the messages that have no reactions, leaves us only the one with reactions. Then we do the same group by, the same ts min function, and we're going to name it first message with reaction timestamp. That again gives us a series, which I turn into a data frame. I then merge these two data frames horizontally. So I'm going to end up with a new data frame that has two columns with exactly the names as given here and here. We're going to join on the index because both of them have the sender ID plus receiver ID as index. And here's where I made a mistake. I picked kind of like the wrong how value. How is like essentially inner, outer, left, right join. And I decided for a left join, but then the interviewer convinced me to use an all. But I'm not actually 100% sure if all is what you would want here. So once you have this merged data frame, all you have to do is to subtract two columns and convert it into days. Because we're working with the TS column, you just divide by 3,600 seconds per hour times 24 hours, and then this gives you the unit of days. To get the final answer of the solution, the average number of days is simply the mean value of this average number of days. There's one little tricky part about this, however, though. Not all conversation threads might have a reaction. You can have absolutely conversation threads where there is no reaction whatsoever. So the question then is, what does that do? What does the mean calculation ultimately give you for that? And here's what I told the interviewer. I told the interviewer that in a real world setting, you probably would want to split all your messages into the ones with reactions and the ones without reactions. And then the mean value would really only apply to the messages that have reactions. In this specific case, actually, it's not a big deal because pandas can deal with non-values quite well. And in fact, for some of the conversation threads, this second frame might be empty. And when you then merge it, the values will be filled with non-values. By then calculating a mean at the end, the mean will ignore all the non-values. So the ultimate number you will get out roughly is not quite what you want, but I explained it to the interviewer how you would probably strategically make it better, and he totally accepted this as the right solution. So the non-values is really what the tricky part is here in this exercise also, and what you have to argue with the interviewer about. So let's see how ChatGPT solved that problem. So here's what I asked ChatGPT for question number 3. First I said, well done for providing a perfect solution to question number 2. Then I said, last question, what's the average number of days from when the conversation thread started to when the first reaction was used? And this is the solution ChatGPT provided. First it imports the data, again, of course, as a data frame. It then creates a new column called dates and thread start, and it tags each message in our data set with a number of days that message falls in relation to when the thread had started. It uses kind of like a seemingly confusing arithmetic, but it's not too different from what I've done, where I create two data frames, I calculate the min dates for the thread, and then does some subtraction. So that seems to be fine. A message that was sent on the same day the thread was started would get a 0. A message that was sent 3 days after the thread started would get a 3, and so on and so forth. So it's just the number of days where the message falls within the conversation thread. The next section is the one where it gets really interesting. So ChatGPT filters this data frame on all the messages that have at least one reaction. It then groups by sender receiver. Remember, that was a unique identifier for a conversation thread, and then slices out the days since thread start and takes the average of that. So for every conversation thread now, you get an average value of days since thread start, but we filtered that on messages that have reactions. That gets it actually very, very close to what we want. But ChatGPT really should have taken the min value here, because you can have multiple messages with reactions in a conversation thread. You would get multiple days back, and then you take the mean of that. That's not quite what we want. The question explicitly asks to when was the first reaction used. So this should be really a min function. Once you have that, all you have to do is to take the mean value of this data series, which gives you the average number of days. Another slight problem I have with this solution is by filtering on messages that have reactions, we only are left with conversation threads that had reactions, but we're completely neglecting conversation threads that had no reactions whatsoever. That does not change the mean value, and it doesn't add any error to the mean value, and in fact my calculation would have gotten very likely the same value as ChatGPT's. However, it's a nuance ChatGPT just glosses over, and I discussed with the interviewer at least that you probably want to segment your messages into ones with reactions, the one without reactions, and then the mean value would apply to the ones with reactions only. ChatGPT also says, oh, you could just calculate this also for all messages by just removing this has reactions filter. That is unfortunately not a solution to the problem. So let's see if we can ask ChatGPT to correct this mean error. So to nudge ChatGPT, I'm telling it the following. Almost correct. You are calculating the mean of days since thread start, but we really want the days when the first reaction happened. So ChatGPT needs to understand what I really want from it is to replace the mean with the min. And it seems like it does it so gracefully. The code here is exactly the same as in the earlier solution, with the only difference that the mean is now replaced with a min. And lo and behold, this gives us the right answer to the problem. So where does this leave us? ChatGPT solved question number 1 insufficiently, only with substantial nudging, and it kind of didn't get quite right the nuance with like swapping the receiver and sender ID. It then knocked question number 2 out of the park, and it also references the right solution in number 1, which was really impressive. And then question number 3 was again kind of like a mixed bag, where it gave us really good looking code, but then there was a rather big logical mistake in it. I will also say that in preparation for this video, I've ran this exercise many times, and ChatGPT seems to generate every time slightly different answers. Sometimes the answers are closer to the true solution, sometimes they are a little bit further away. If you run the same thing on ChatGPT, you will also very likely get different answers. And that is also slightly problematic, right? Because it seems to be almost like a little bit like a guessing game at this point, where ChatGPT like may generate the right answer, exactly the right answer, or maybe generate something that is slightly closer to it. And yeah, I don't think it would have passed the interview because of that. That said, ChatGPT is an amazing tool. Somebody on the internet put it really well. If you know what the solution looks like, ChatGPT can be your best friend. And in fact, I have been using it quite a lot. It's super useful to bootstrap you on some coding exercise, and then you can make the modifications to get the right results at the end. It does already a superb job at that. I also found it quite interesting that ChatGPT's solutions looked quite different in some of the answers than to my own. In that case, it's almost like your coding buddy that gives you an alternative solution, and you can compare it to your own solution. Well, I had a ton of fun teaching ChatGPT how to crack the Facebook Data Science Coding Challenge. I hope you enjoyed it too. Leave your feedback in the comments, and don't forget to hit the like button. Until next time.